Over 7 episodes, we built a multi-tenant platform that does not leak, knows who is asking, survives its noisiest customer, can be changed while running, and can answer questions about everyone without exposing anyone. Now, it has to be a business, which means a new customer signing up at midnight has to exist and work without you. You have to know which of your customers are costing you more than they pay. And when someone ships a bad deploy on a Thursday, it has to be a problem for some of your customers rather than all of them. This is the finale, and it is about the operational facts that decide whether an architecture survives having customers. Start with onboarding, because it reveals whether your tenancy is real. Creating a tenant should be one path, automated, that produces a customer who works completely. The tenant record, seed data, roles, quotas, and whatever the isolation model requires, which in a silo means an actual database. If any of that is a manual step, a run book, or a person, then your growth is capped by that person. And worse, every tenant created by hand is subtly different from the ones created by the code. Then you get the class of bug where something works for every customer except the 3 that were onboarded during the migration in March. And provisioning must be idempotent and resumable because it is a distributed operation that will fail halfway. And a half-created tenant is a customer who can log in and see something broken. Now money, and this is the question pooled platforms cannot usually answer. Your bill arrives as one number. Your revenue arrives per customer. If you cannot connect those, you do not know your margins, you know your average, and averages hide the tenant using 40% of your database while paying the smallest plan you offer. So attribute cost per tenant, even roughly. The same metrics that let you catch the noisy neighbor in episode 5 are the ones that tell you what each customer costs, which is why that work pays twice. And the answers are usually uncomfortable in a useful way. A handful of customers cost more than they pay, and the reason is almost never that they are big. It is that they use one specific feature in a way you never priced. That is a product conversation, and you cannot have it without the numbers. Then the deploy question, and it is the one enterprise customers actually care about. In a single pool, every change is a change for everybody at once. One bad migration, one bad release, and the number of affected customers is all of them. The idea that fixes this is cells. Run several complete copies of the platform, each holding a subset of tenants, and deploy to one first. Now a bad release is an incident for a fraction of your customers, and your rollout is a series of decisions instead of one leap. It costs you real complexity because now you have many things to operate instead of one, and you should not do it on day one. But it is the honest answer to how many customers does a bad deploy affect, and at some point somebody with a large contract will ask you that question and want a number. One more, and it is the one that gets discovered during the emergency. A customer calls and says, "Someone on our side deleted everything this morning. Please put us back to yesterday." In a silo, that is a normal restore. In a pool, their rows are interleaved with everybody else's in one backup. So restoring them means extracting one tenant's data from a snapshot of the whole platform and merging it back into a live database without touching anyone else and without breaking references. That is not a restore, it is surgery. And the time to write it is not while a customer is on the phone. So build the export and re-import path early and rehearse it, because per-tenant restore is the clearest example of a cost that pooling defers rather than removes, and it comes due on the worst day. So that is multi-tenant SaaS data architecture, end-to-end. The leak, the isolation model, the engine enforcing it, the context that makes it work, fairness, change, analytics, and the operational reality. Every one of those was a decision, made deliberately instead of discovered during an incident. The full series playlist is linked in the description. Next series takes the same treatment to strangling a legacy mainframe into event-driven cloud services, which is the one most of us actually inherit. See you there.